Welcome to the flexible AC transmission system second lecture. In first lecture, we have discussed about the course content of this fax devices and little history and the background and its evaluation of the fax. Now, we shall discuss in detail actually the concept of fax and what is its significance. As we have understood it, actually the conventional AC systems, that is its power transfer capability is mainly actually limited by few constraints. These are thermal limit, transient limit, voltage limit and the short circuit limits, and this limit can be enhanced by the fax devices. That is what it said. These limits define the maximum power transfer capability can be efficiently transmitted through the transmission line without causing damage of the equivalent damage of the equipments of the transmission line. Now, fax device is an avenue that fax devices refers to the system which consists of the fast acting power electronics controller along with the power system devices to enhance the controllability and the stability of the transmission system, and it increases the power transfer capability of the existing system. And what is the advantage of fax? Fax provides stability, controllability and enhanced power handling capability of the existing system. In a subsequent discussions, we will elaborate these topics. Now, fax comes with few features, that is series impedance. We can change the series impedance of the network by a fax controller. Thereafter shunt impedance and current voltage and phase angle control, and it can also damp actively the oscillations, power oscillations. This is a simple two machine model where actually energy is transferred to the point A to point B with the impedance X. Transmission lines is considered to be the lossless, and this is the series impedance X. So, power electronics can control this inductive and the capacitive power network and thus control the X, and thus it can control the power flow between the two lines. Moreover, it can change the delta and it can control the power flow between through this line. Thus, in a series compensated transmission line, it can change the series impedances, it can change the power angle, and thus it can control the flow of current point A to point B. Now, let us take a typical example. Upper one is a radial parallel system and another is a mesh system. These impedances is basically transfer this series impedance, where this impedance can be actively controlled by the shunt by these fax devices, and these are basically the series injections of the voltage or the phase angle, and thus power flow from this point A to point B can be similarly be controlled. Another is a mesh network, say point A, point B and point C. So, A and B are the generating unit and C is a consumer load point. We require to send power point A to point B. Fax device and can monitor the power flow between A, B and C line. Now, let us consider the simple power flow between the uncontrolled parallel paths. Here the impedance of this line govern the power flow between this point A to point B. Since upper one have a impedance X, another has been a 2X, this power flow will be actually 2/3 of the power will be flow through this upper line and 1/3 of the power will flow to the lower line. But if we try to increase this actually the capability of this line of the lower transmission line, it is sometimes self defeating, because ultimately the power carrying capability will be ultimately determined by the impedance of this line. And another solution we can think about, that is with the uncontrollable line which is power governed by the impedance of the line, we can put a HVDC link in between. This HVDC link is controllable, thus it can take x amount of power and 1 minus x amount of power will be flown to the uncontrolled line. Since x is controllable, thus 1 minus x is controllable, and we have to maintain the power flow of this line by, it is governed by its thermal point, operating point by thermal limit, dielectric limit and its steady state limit. Same way we can go for the solution of the fax devices also. Let there be an uncontrollable line upper one, which may be the old one. Now we can place a new controllable line with the fax device, placing a fax devices. So this is a variable impedance. This variable impedance can be controlled, that power, x amount of power which is flowing through this lower line, thus it is controllable, and thus 1 minus x should be actually limited to the thermal limit and other limit as governed by the authorities. Now same way, instead of controlling the impedance, as we know that P equal to V1 V2 by x into sine delta, we can change delta, and this is called power angle regulator. This works better when power angle is very low, it is less than 30 degree, something like that. Then it can, by changing the delta, we also control the power flow x through this actually fax control line, and ultimately other part will carry 1 minus x amount of the control power. Next, let us consider the mesh network. Take it a critical case where generation point A has a generating capability of 2000 megawatt, and it has been connected by the line C, and which has a limit of power carrying capability is given by 1500 megawatt, but ultimately the consumer require 3000 megawatt of power. Unfortunately, since this line AC cannot take that amount of power, ultimately power required to wheels through the network AB and AC. Now in a power system where there is a different stakeholder and different network owned by the different people, it may be so that this line AB is owned by the another distributor network, and they may charge while carrying current through this network. Smaller amount of current is carried, then less amount of power will be, then less amount of tariff will be there, and thus power available to the consumer will be costlier. So we can reduce the power flow through the line AB by injecting, by having a solution given by the fax. We can insert a series impedance, variable series impedance, to reduce this actually impedance of the line, thus it will enhance the power carrying capability of the existing line, and it actually reaches to actually another 250 megawatt of power. Thus only 250 megawatt of power is actually wheeled through the line AB, and thus it reaches through C. So that actually the wheel power cost decreases in this case while using a fax devices. Similarly, we can also increase the for C is a network with a TC-SCR. So previous slide, it uses actually TC-SC. It is thyristor control series compensator. Now it is thyristor control series resistor. These are the nomenclature of TC-SCR. All the nomenclature will be given in a subsequent time. In this case, instead of this putting the line TC-SC in this line, we will put a TC-SCR in the line BC, and we will actually, and thus power flow, since the impedance of this line was least, it will carry a most amount of power. So inserting an extra impedance, it will actually degrade the power handling capability of this line. So thus, according to the impedance matching, more amount of power flow will cause through the line AB. Now what is actually disadvantage of the previous? Advantage of this previous advantage is that it has increased the power handling capability. So it may touch the thermal limit, and here without inserting this device and we have inserted a device here and we have increased the extra impedance, then also the same has been replicated to the line AB. Now, here advantage of it that here stability is more, but since impedance has been increased, the losses will be more. But another solution can be given by phase angle regulator. Instead of actually injecting series reactance capacitor or inductor, so we can insert a power angle regulator which will increase the delta in between the phase in between this point A to C, thus it can increase the power handling capability of the line. So, these are the three solutions available, and depending on this actually thermal limit, depending on the environmental condition, dielectric limit, current values, all those consideration, different solution will be chosen. So, same point in a different ambient we may choose different solutions. So, different kind of FACS devices will provide a unique solution for a particular case. Now, what governs these limits? One is thermal limits, and generally thermal limit is designed considering the worst ambient condition, and overhead thermal line is a function of the ambient condition and so there is lot of leeway to take advantage of the present ambient condition. If we know that actually actively the what is the present ambient condition, then we can overload the line and smartly, and thus power handling capability of the line can be increased. Same way dielectric comes with the actually the voltage level, since actually we can increase the dielectric limit by because dielectric also limits also works in a purpose of the voltage rating, and it is also for the worst environmental condition. For a normal operating condition, we can easily increase the voltage limit by 10%. Thus, FACS enables us smoothly carry 10% extra power without any much change in the network. And stability is a very big issue in the power system. There is a different kind of stabilities. For example, there is a transient stability, there is a dynamic stability, there is a steady state stability, there is a frequency collapse, there is a issues like voltage collapse, synchronous reactance and so on. FACS devices can improve on all those aspects of the stability. Now, let us talk about transient stability, dynamic stability and steady state stability. These all will be discussed briefly now, and this I am noting down in separately, so that these are the very important aspect of the power system: collapse of the frequency, collapse of the voltage and subsynchronous reactances. Now, transient stability. Example of the transient stability will be actually when a loaded line have a LG fault or line to line fault, then all of a sudden there is a huge change in the dynamics of the power system. So, this is actually severe fault in heavily loaded line. Then FACS device can be used to mitigate this fault and increase the stability of the system. Same way, dynamic fault. If the system has a power oscillation and thus the torque angle oscillates, we require to damp out that oscillation actively, and that is also possible in the FACS devices. Since this term, if it is more than is positive, it means that power is increasing, and considering that this actually actually sigma is actually less than 90 degree, then in that case we require to increase the transmission line capability. Similarly, if it is less than 0, we require to decrease the transmission line capability, and thus by doing that we can actively damp out the dynamic oscillation and thus enhance the dynamic stability of the system. So, it is stability, we require to maintain the voltage and current and power in a normal to the operating condition. If all of a sudden disturbance is there, sudden sag is there, let us say a transmission line actually touches by a tree, then after every 10 millisecond or 20 millisecond you got a voltage sag. So, in that condition series injection can actually actively mitigate that sag. So, for example, series capacity compensation can be used to mitigate small power fluctuations. Now, let us come into the again the two machine model, and we assume, and this is a phasor diagram of it, and where the angle between them is delta and I almost perpendicular to the EL. Now, we shall calculate the power of the receiving end, same way we can calculate the power of the sending end. So, this is E1 and this is E2. So, from there an angle between them is delta. So, real power of the sending end is IP1, it is given by E2 sin delta by x. Similarly, the reactive component of the current is given by E1 minus E2 cos delta by x. So, P1 equal to E1 E2 by sin delta by x. This is the sending end power. Similarly, reactive power from the sending end will be given by E1 minus E1 into E1 minus E2 cos delta by x. Thus, as we understand, by changing x we can change the transmission capability of the line. Similarly, by changing delta we can change the transmission capability of the line. By increasing or decreasing the value E1 and E2 we can change the transmission capability of line. Same way, by actually controlling this term we can control the value of E1 and E2 in the line. So, if we wish to increase the power limit or decrease and we require to change the series impedance of the line, this will be the power curve. Since E1 by E2 sin x sin E1 E2 x by x sin delta is a curve, and thus if you increase the decrease the value of x, subsequently for x1 you will get this one, subsequently x2 will be get this one, where x equal to actually 0.5. So, this power handling capability ultimately governed by the thermal and other stability issues of the system. Same way, we can inject the voltage in phase. It can be easily done by a tap changing transformer, and thus also the value of E between E1 and E2 changes, reactive power as well as the real power can be changed, and the new current changes to I1 to I2. Now, we can inject current perpendicular to we can inject voltage perpendicular to the current. Then that helps us to change basically the phase angle. So, when we inject the actually perpendicular to the line voltage, is mostly changes the active power of the system, and when we inject the current in series with this actually E1 and injected voltage almost in the phasor, then voltage regulation can be done by this method. Now, there are different kind of shunt devices. Shunt connected controller, it inject current, series connected controller, it inject voltage. This combined series controller and combined shunt series controller. And another type is it injects basically the impedance, these are called variable impedance type VIT, and another type is source voltage converter. So, classification can be done based on what kind of, whether it is inserting impedance or the voltage source into the system. Now, these are the few nomenclature which will be frequently used in our subsequent discussions. Students are required to note down and familiar with these acronyms. So, this is basically the variable impedance type controller. So, it insert impedance. So, VSC, it is a static work compensator and it is a shunt connected device, and TCSC, in few slides before we have seen TCSC, that is thyristor control series compensation, is an active capacitor and it is a series connected device. Similarly, thyristor control phase shifting transformer, it is used for PAR, power angle regulator, and other type of the fax devices are voltage source converter. These are STATCOM, this is shunt connected, this is SSC, triple SC, it stands for static synchronous series compensator. Thereafter you have interline power flow controller, that is combined series combinations, and thereafter you have UPFC, that is unified power flow controller, or UPQC, unified power quality conditioner. For power quality we say power quality conditioner, and the fax we say power flow controller. Now these are the pictorial representations of different acronym which I have just explained. This is the STATCOM. This stands for the step down transformer. Since operating devices cannot match the existing power line voltages, so it is required to step it down. It is basically a static solution of synchronous over excited synchronous generator. A synchronous generator can provide this solution also, compensate the active power and also control the VAR of the line, but it can actively do that. But advantage is that only it has to feed the switching loss, there is no power, there is no prime mover is required. Thus efficiency of the system is quite high in this case. And when we use a voltage control current source inverter, then we shall use this kind of topology and followed by a DC link capacitor. If we use current source inverter, generally we use an inductor. Current source require a high value of the inductor, and for this reason this voltage source solution is cheaper and effective. Most of the application we found that STATCOM is operated by this voltage source inverter. Voltage source inverter or current source inverter, if it carries a storage device like in a distributed generation like solar cell or battery, then it can also inject the active power, it can also compensate or give the active power to the system. Then it will be a storage device with the fax devices, and this is the STATCOM with the battery. And now let us come to the figure SVC, static VAR compensator. Static VAR compensator consisting of family of the fax devices and the power quality devices. So this is actually TCR, this is TCSC, thereafter you may have a line filter, thereafter you have a uncompensated capacitor, uncompensated inductor, and this is actually the TCBR. This stands for the actively damping the circuit. Now let us consider the fax devices, which is basically SSC. It is a series controller. So again it is same as a STATCOM, but it requires a series injection, and ultimately it can also have a current source converter topology, but it is not very popular. For this reason here voltage source converter topology has been shown. And same way this SSC can come with the storage devices, so it can inject the voltage and current in phase and quadrature, and it is quite versatile device as far as series compensation is concerned. TCSC essentially deals with the variable impedance part component of it. By changing the triggering angle of the thyristor, the impedance can be controlled, and thus you can control the impedance of the line by this transmission system. Same way, if you have a TCR, and we will have this kind of system. Please note that thyristor should be connected in the line where actually inductor is connected. We cannot connect thyristor in series with the capacitor. Why it is so? I left this question to the student. Now let us come to the combinations of the fax devices. This is combined shunt and series compensated controller, and this is called TCPST. This is essentially a phase angle regulator, and this is a UPQC or UPFC. This is a series shunt combination. This part acts as a STATCOM and this part acts as a triple SSC for the series compensation. So, altogether advantage of the series and shunt both are captured here. So, both we shall capture in the next class what are the advantage of different kind of shunt and the series network, and we shall in detail we shall talk about this what are the application of the different kind of fax controller in next class. Thank you.